Hey everyone, this is Muskan. Today I'll be talking about substitution theorem. It is a fundamental theorem used in electrical circuit analysis. It helps us simplify complex circuits. It states that any branch of a network can be replaced by another branch having the same voltage and current without affecting the rest of the circuit. Now let us understand this statement with the help of an example. This is the example circuit. This circuit consists of a voltage source of 10 volts and two resistors of 4 ohms and 6 ohms. According to the statement, if we replace any of the elements of the circuit with any other elements or combination of elements, the parameters like current and voltage drops at each element does not change. Let us first calculate the current and voltage drops in this circuit. We calculate the current in this circuit with the formula of I is equal to V by R equivalent. Here V is 10 volts and R equivalent is given by 4 ohms plus 6 ohms as these two circuit or resistors are in series. When we calculate the current, we get the value as 1 ampere. As we have the current, we can calculate the voltage drops across each resistor. We get the values as 4 volts and 6 volts. The voltage drop is calculated by using the formula V is equal to IR. Now let us try replacing this 6 ohms resistor with a voltage source and current source, and let us check if the parameters change or not. This is the circuit when we replace the 6 ohms resistor with a 6 volts voltage source. Now we calculate the current in this circuit as 10 volts minus 6 volts by 4 ohms. With the help of the formula I is equal to V by R, we get the same value as the previous circuit as 1 amperes. Now, as the current is same and the resistor value is same, we get the same voltage drop at 4 ohms as 4 volts. In the parameters did not change when we replaced the 6 ohms resistor with a voltage source. Now let us check if the parameters change when we replace it with a current source. Here we have replaced the 6 ohms current source, 6 ohms resistor with a 1 ampere current source. Since it is a direct current source, we can tell that the current passing through this circuit is 1 amperes. The current value is same. Now we need to calculate the voltage drops across 4 ohms resistor and current source. The voltage drop across 4 ohms resistor will be the same as the current value and the resistor value is same. That is V is equal to IR. When we substitute the values 1 and 4 in the formula, we get it as 4 volts. Now, to calculate the voltage drop across the current source, we consider the voltage drop as V. Then, according to KVL, we write the equation as plus 10 volts minus 4 minus V is equal to 0. This we write with the help of KVL that states the sum of voltages and voltage drops across the circuit is equal to 0. When we solve this equation, we get the V value of V as 6 volts, which is the same value or voltage drop in the previous two circuits. Here, the value of voltage is 6 volts, and here the value of voltage drop is 6 volts. The current, the voltage drops across the three circuits when even by replacing the sources is the same. So it proves that the substitution theorem, any branch of a network can be replaced by another branch having the same voltage and current without affecting the rest of the circuit. In this example, we replaced the 6 ohms resistor with a 6 volts voltage source and a 1 ampere current source. but the parameters did not change. Now, here are some applications of substitution theorem. It helps in easy circuit analysis and calculations, used for circuit transformation into equivalent forms, useful in testing and verification of circuit behavior, helps in fault detection and troubleshooting, applied in design and optimization of electrical networks, used in communication and electronic circuit analysis, helps in power system studies by simplifying network sections. In simple words, we can say that the substitution theorem is used to reduce our calculations and easy circuit analysis. In conclusion to this, I would like to say that substitution theorem allows replacing any branch while maintaining the same circuit behavior. The circuit behavior across the elements does not change. Thank you.